Pre-calculus students, we are moving on to our review of 6.4 through 6.6, and honestly guys, this was all the graphing. Okay, so here we need to remember what sine, cosine, cosecant, secant, tangent, cotangent, what the graphs look like, okay? So hopefully you remember that the major difference between a sine and a cosine, I'll do these in purple, sine and cosine, is where they start, okay? The sine, if you remember, that goes along with y, well, when we have an angle of 0, the sine is 0, okay? So we start right here at the middle, and as our angle increases, we go up, 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 up to a max, and then we come back, and then we go down to the min, and then back to complete one full cycle. Alright, now for cosine, because it is the x coordinate, or cosine goes with x, well, at an angle of 0, cosine's a max, right? It starts up at the max, and it drops down, and then goes to the minimum, and then heads back up to its maximum, okay, and to complete one full cycle. Alright, now while we're at it, we might as well take care of cosecant and secant. Please remember, anytime if you're asked to graph a cosecant, secant, or you're not going to be asked to graph, if you're going to have to recognize a graph, remember that cosecant, secant are the reciprocals of the sine and cosine. So when I take the reciprocal at every place, I have some problems, right? This is a 0 here, a 0 here, a 0 here. When I do 1 over 0, I can't do it. I get asymptotes. So whenever you have a 0, or whenever it crosses that midline, you know there's going to be a vertical asymptote. And then what we do, if you remember, we just finish off by making these kind of little U's or parabolas. Something like that. Alright? Well, honestly, guys, the same thing happens here with secant. Anytime there's a 0, there's an asymptote. And so I know that I would have like a little u there, and another u right there, and then I would finish by doing that. Okay? Now, of course, this goes on forever and ever and ever. This is just one little section. Okay? Okay. Now, for tan cotangent, a little bit different. If you remember, tan is y over x. Alright? And so if we think about it, at 0, we can do y over x because that's 0 over 1. So we know that there's going to be a point at the starting point of tangent, and then it will have an asymptote, and then it'll have another point. Alright? And that goes the same way on the other side. So we know that our original tangent, again, you guys have to envision this as like quadrant 1. Tangent is positive in quadrant 1, so I'm going up first. But then at 90 degrees, or at pi over 2, it's undefined. And then on the other side, or in quadrant 2, it's negative. So something like that. Well, we could keep going, just kind of finish this up. So something like that. So notice tangent, a normal tangent, is one of these. For cotangent, which is x over y, well, now it would be 1 over 0 at an angle of 0, right? So we can't do that. So this one starts at an asymptote, goes to a point, asymptote. Same thing on the other side. And so then again, please remember, it starts at an asymptote, but in quadrant 1, cotangent is still positive. So I need to start here, come grab the point, and then go down into quadrant 2. Same thing on this side. And what I really want you to drive home is the overall shape of cotangent, is something like that. Okay? Wow. So there is a big review. Let's go through this chart hopefully pretty quickly. I think I touched on a good amount of this stuff already. So I already said, how do they start? Well, for sine, we know it starts at the middle. Alright? Cosine has to start at a max or min. That's the main difference between sine and cosine. Okay? For tangent, we know that our first point was a point, And for a cotangent, it was an asymptote. Alright, so those are the things that we need to remember about how they start. For period, sine, cosine, cosecant, secant are all the same. We use 2 pi over b, absolute value of b. Same thing over here. Alright, because it takes a full 2 pi to complete an entire cycle of sine. For tangent and cotangent, though, it only takes 180 degrees, or pi. So that means that we only do pi over b and pi over b. That'll be really important for when we ask you to kind of recognize how to graph things. Sectioning, how many quadrants are there in 2 pi? There's 4 quadrants, so 4 sections. If we're only using pi for tan and cotangent, well, how many quadrants are in pi? Only 2. Alright. Sine, hopefully you can tell, this purple, it's never going to have any asymptotes. It's fine. It always has real possible solutions. Problem cosecant definitely has definitely has asymptotes. So we would say that cosecant has asymptotes and secant has asymptotes. And then, of course, yes, tangent and cotangent have asymptotes. Which ones have domain all reals? Now, if you remember, domain means that there are no places, there are no gaps in any x values, alright? So, which one is continuous forever and ever and ever? Yep, it's sine. Alright, so sine and cosine. Dash dash, because those have asymptotes. Alright, so there's a brief review of graphing. Now we're going to jump in and kind of see how some of this stuff works again. Alright, excuse me. So, move down, sorry about that. Let's remember a few things here. Alright, this negative is a flip over x. This 5 is either the amplitude, but I also want you to remember that's kind of like a vertical stretch. And then this last number, the 3/2. What that is that's the horizontal stretch or shrink. And what I want you guys to do is I want you to understand that this right here, this affects the period. Alright, and if I just want the period for the following equations, well then this is what I'm looking at. The 3/2 is the value that I care about. So now this is tangent. If it's tangent, then I'm using pi over 3/2. Now, we don't like dividing by fractions, so what I'm going to do is instead I'm going to multiply by 2/3. I'm going to get rid of that. So, 2 pi over 3 is my period. Alright, hopefully that rings a bell. For the next one, similarly, we're going to look for that b value, but please, please, please remember, this 7, it's right next to the x. I don't want that. I want my x to have a coefficient of 1. So I'm going to rewrite this. And I'm going to factor out that 7, or divide out that 7 from both pieces. So when I divide 7 from 7x, I'm just left with x. When I divide 7 from pi, I have pi over 7. Alright? Now hopefully that makes sense, right? We could go ahead and we could redistribute this back in, and yep, 7 times pi over 7 would get us back to pi. So we're good. Now, we need to remember some things. Again, 15 is the amplitude. I don't necessarily care about that if I'm trying to find the period. Pi over 7, this ends up being the phase shift. So maybe we'll write that down, even though it's not really helping us with the period. But that's a good refresher. Yep, we know that this would go left pi over 7. This is the number I care about, this 7 here. Okay, I know that b is 7. I know that I have a sine function, so I know I have to do 2 pi over 7. Oh, I don't even have to reduce that. That's just the period. Alright? Now remember, that's just the period. We would want to, if we were graphing, we would need to find the sections by dividing by 4 in this case, and then we would need to plot and do a whole bunch of other stuff that we're going to do on the next page. Alright? Okay, so when we state things, and by that I mean asymptotes or zeros, what we do is you need to find one of them. Alright, so you state one of them, and then you add or subtract the distance to the next one. And I'm going to put that all in parentheses because that all has to be multiplied by an n. And why does it have to be multiplied by n? Because it's not just the next one, it's the next one after that, and after that, and after that, and so on, and so on, and so on, and so on, forever and ever. So that's why we have to put in that letter n to show that it's going on forever. Okay? Now the last thing, and we had to do this on number 2, please make sure that you're always fully factored. Okay? Be sure to get the equation. I'm going to come over here. Fully factored. And by that, what I really mean is x must have a coefficient of 1. Alright, x must have a coefficient of 1 in order for us to be ready to graph. Which is what we're going to do right now, okay? So we're going to flip, we're going to do a couple of examples here, and we're going to call it a video. So, first things first, when we look at this one, we notice that it is secant. I know that secant, I'm going to have to graph the cosine first. Alright, so I'm going to rewrite my cosine, and I know what I'm going to end up doing is I'm going to dash the cosine, and then I'll make the function that I really want, excuse me, a solid color. Alright, so let's take a look. This is definitely already ready. I know that because there's already a coefficient of 1 with the x. So my b value is 1, which means I can get the period by doing 2 pi over 1, or it's really just 2 pi. Alright, for sectioning, because this is secant and it goes with cosine, I know that it's going to span 4 quadrants. So I'm going to divide it into 4 sections. So 2 pi over 4, well, that's pi over 2. Alright, so these are big things that I need because now I can go and I can 1, 2, 3, 4, 1, 2, 3, 4. Now I know what the sections are. I'm going to say this is pi over 2. Next one's 2 pi over 2, which is just pi. The next one is 3 pi over 2, and the last one is 4 pi over 2, or 2 pi. So please remember how I'm doing this. I know some people had trouble the first time through. I'm just adding over and over, or I'm counting, right? I'm counting by pi over 2's. Pi over 2, 2 pi over 2, 3 pi over 2, etc. Okay? So same thing the other way. It's getting a little sloppy. Sorry about that, guys. Alright, next thing I need to take into consideration. Well, I know that my amplitude right here is 3, which means instead of just going from 1 to -1, I'm going to go from -3 up to +3. That's very important. Okay, we're getting there. This is a cosine, so I know it has to start at either a max or a min, and hopefully you guys can agree with me. I'm going to start at a minimum. I'm going to start at a minimum because it is a negative cosine curve. Alright, so I know I'm going to have to be down here at -3, and I also know, excuse me, maybe I should have done this first, but hopefully you guys are with me. I have a phase shift of pi over 2 to the left. Why is it left? Because it's positive pi over 2. So I move over pi over 2 to the left. I already said that we're going to have to start at the minimum, and now I have my point, and now I can get all of the points, all the points. Because now I go ahead and I dash my curve. Not the best, not the worst, it's okay. Alright, so now I have the cosine curve graphed, but I want the secant. So if you remember, anytime there is a 0, there needs to be a vertical asymptote. And again, I hope you understand why. It's because when you go and you take any number that's on this green curve and divide it, or take the reciprocal of it, you can't take the reciprocal of a number with 0. Or the number 0, I should say. That is undefined. Alright, so now I have my asymptotes. I finish by sketching in my little u's, or mini parabolas. Okay? And they have to be outside of the curve. Something like that. Okay? So, for notes, my purple curve is the function that I was looking for. Alright? Alright, we're getting there. Let's see what's going on in this last one. Alright, so, I like this cotangent. The problem is not ready yet. Okay, I see this 2. I don't want it. I need to factor that 2 out. So when I take 2 out of 2x, I'm left with x. When I take 2 out of pi over 2, remember, it's a division. So this actually ends up being pi over 4. Alright? So now I know that I can get my period. It's cotangent. So remember, it's pi over my b value of 2. That's good. My sectioning would be pi over 2, and then I would divide that by 2. Again, cotangent only takes 2 quadrants, so I divide by 2. But instead of dividing by 2, I'm going to multiply by 1/2, so I can see that my sectioning that I need is pi over 4. So I can sketch my 2 sections on either side. I know that it's going to go pi over 4, pi over 2, negative pi over 4, negative pi over 2. Whoops, negative pi over 2. Again, how did I get it? I just counted by pi over 4 is counted by my section. Pi over 4, 2 pi over 4, 2 pi over 4 is pi over 2. So that's why that is like that. Alright? Now, cotangent, if you remember from the other page, it kind of oh my gosh, I'm so bad at graphing cotangents. Alright, it starts up and goes down. The other way to think about it is, well, let's see here. I know that I had a phase shift of pi over 2. Excuse me, pi over 4. My bad, guys. So I know that right here, when I move over pi over 4, it has to be an asymptote. Okay, so that kind of dictates the rest. So point, asymptote, point, asymptote, point. Alright? And again, if we moved pi over 4 to the left, then this is kind of like my origin, or my starting point, like my 0 degree angle. And as I move into quadrant 1, I need to be positive. So I have to be positive, and then come down like that. And that should give you the rest of this curve. Alright? Okay, almost done. State the zeros. Well, zeros, I would start probably at this one. So x equals, you guys could put 0. You don't have to. But I'm going to say 0, plus or minus, and then how far is it to the next one? Well, it's 2 sections, or pi over 2. So pi over 2 times n. Asymptotes, slightly different. I would say, again, these are at x equals. However, I want to pick, doesn't really matter which one. I'm going to pick the positive one, so I'm going to say pi over 4. And then what's going on here? I know that it takes, I'm going to have an asymptote every 2 sections again. So pi over 2n. Alright, so there was a brief reminder, maybe not brief, but a little refresher on graphing. Hopefully this stuff is making sense to you, and of course we will practice in class. Have a good one.